Hello everyone, welcome to this session. In this session, we are going to talk about Prometheus monitoring system and time series database, which is also a open source monitoring solution. We have seen what is Prometheus, difference between Arceus versus Prometheus, and how is the architecture design, and the functionality of alert manager availabilities and features, and time series database definitions, and how it can be used. So in this session, we are going to talk about PromQL. PromQL is Prometheus Query Language. So what PromQL is offering, which is not available in other monitoring solutions? Let's see. PromQL provides a functional query language. It lets users select and aggregate time series data in real time. So based on the timing, it goes and fetches the data and put it into the database. Further, you can using some query language methodology, you can show it as a graph or you can see it as a tabular format by using the expression browser or Grafana. The Prometheus query language allows you to slice and dice. That means the broader data into in a very catchy manner, like you can see it in a proper graphical view representations or tabular representation when applicable, and from that you can get some information for your day-to-day work and future actions whatever is needed. So time series selector. So there are two types. One is instant vector and range vector. Instant vector is like you can see based on the over the time the S1 sample it takes, S2 sample it takes, S3 samples it takes, S4 sample. So whatever the values it takes it and showing it in the manner. The range vector is like over the time T0 to T2 how many samples it has captured, those things you can show it in the graph. So it's a only metric name which is instant vector is like one value per and that over the time, and the range vector is between time what all is captured, those is captured with brackets the end of the vector selector. Then the metric types, there are four metric types available currently. One is counter and cache and histogram and summary. Counter and cache, there is both are similarly by look wise it is same part. The difference is that counter which always goes up, how many people entered into the mall, it always going to up by the end of the day. And but kaj, what is the temperature now, the same can go up or can go down, so that is the difference. So just thing like counter means you can count a represent number of requests served, number of requests served, number of order received, task completed, and number of error received. Those things keep on going to increase only. It is never going to decrease. But Kaj is like temperature can go up down. Memory usage. Sometimes it can be 1 GB memory used, sometimes it can go down. Because once the job is completed, the memory will be freed. Then it will be reused for other application purpose. So that is how. So that is the difference between counter and cache and histogram and summary. Again, both are again similar. There is a difference. Histogram means suppose you have over the name you have identified how many trees height is this much, how many trees height is this much. So between the range you are giving, right, 100 to 150 height, how many trees, 150 to 200 how many trees are available, 200 to 250 how many trees are available, 250 to 300 how many trees are available. So this is how we work. So it is a histogram. Histogram samples observe usually things like request duration, response size, and count them in a configurable buckets. Summary, similar to histogram. Yeah, summary samples observation usually things like request duration, response size. Like suppose you consider that HTTP request. Within 1 second, how many request response is received? Within 2 minutes, 2 seconds, how many request responses? Sometime over the 4 seconds means that and all we got to analyze why it takes 4 seconds when normally it experts within seconds. So those things under purpose, the analysis purpose, you can identify and what kind of request is that. Sometimes it can be a music download, sometimes it can be a just what is the time, uh, those things. Google always gives for whatever it is very fast only, but some applications, something can take some time, extra time, something will be milliseconds. Those things you can put in a graph, identify is this usual, abnormal, those kind of analysis will help and take future actions. So this is how we told the whiteboard monitoring is given by Prometheus, which is now yes. And operators. So what are operators? Basically, we have all the operators which we have seen earlier, like you have equal sign, greater than, less than. All those things are available. Arithmetic operation also available. Logical cells and are unit, unless all those things are available. And then built-in aggregations like sum, minimum, maximum, average, standard deviation, standard variance, count, counter value, bottom, bottom k, top k, content. These are like the topmost three process. In if you give top command, it will list some 100, 10, whatever in that page applicable. It will show these are the process from the top to down, it taking the more CPUs, more memories, like that. So from the like that, in the top three you can see, bottom three only you want those things and all you can put. This is how they have. And two things they have brought is that the operator can either be used to aggregate over all level dimensions or preserve distinct dimensions using by or without. Suppose the top command has all the input like memory usage and processor usage, like that. So many variances available. There are 8 CPUs, and even there is a 10 server, something only you want means by CPU. I don't want CPU. That means without CPU, those things you can segregate, include, or specifically you want that parameter, you include by, or you don't want that parameter without that parameter. So like that, I want only push by push. I don't want push without push. Suppose there are eight possibilities are available, and you want to restrict only two possibility by that two possibility, or you don't want the two possibilities without that two, remaining six will be. So that is how they are given. And then basic functions. PromQL has 46 functions in build, and it's still growing. Most of them are mathematical functions, and they, like some minus, all those things are applicable. And there are time based, like day, month, year, you want minute, hour, time, all those things are built in. Then from this perspective, I could say these are, there are most important is like rate, high rate, and increase, label join, label replace, aggregation over the time, minimum over the time, maximum over the time, average over the time, sum over the time, count over the time. These are the new things which I could see. And rate versus irate is, irate should only be used when graphing volatile, fast moving counters like market and all. Every seconds it will change. Those place and all you have to use irate. Rate somewhere it will be always same CPUs daily. If you see morning 1 to 5 o'clock it will be almost idle, and then 5 to 6 it will, there will be cron jobs that will be running, so it will go high, and then 7 o'clock will be again into average, then 8 the traffic will start. So like that, this will be somewhere you can predict it, and it will be not volatile, it will be like standard format only. You can expect it, and it won't be within seconds, it will go up and down like this. So it will always like predictable curves. In market and all, it will be a volatile, it can go up anytime, whatever can happen in seconds. So those plays and all you have to use irate to get a better graphs. So that's it. And increase, rate and increase both are syntactically same, means syntax wise same, and purpose also my slightly different. And whenever the increase, where it always expects increase purpose, those, like I told, right, counter and catch difference, it can go always up, and the catch is always go down. Those places and all you can identify, and properly you can use rate or increase. Label you can include in join and replace some labels, those are functions are available. aggregation within there is particular range of time. What is the mean? What is the max? What is the average? So by 5 minutes, mean 5 minutes, those graph also will be very suitable to view and nice. The function which I could say as a wow functions. These functions will help you predict the future and you can do many things. Delta functions is like the average unfortunately means sometimes people will tell 100 people came 100 things happened and then what is the average, you will go to middle part. Always that unfortunately have the big drawbacks of hidden distribution and prevent the discovery of outline deviation. So always the quantiles are better measurement for this kind of metrics as they are allowed to understand distribution. For example, if the request latency 0.5 quantile 50th percentile is 100 milliseconds. That means 50% of request completed under 100 milliseconds. Similarly, the 900 milliseconds is 4 seconds. It means that only 1% of the request responded in more than 5 seconds. Suppose you have 100 request came in that 90 requests took 1 millisecond and 10 requests took 4 seconds, then your average will tell that maybe 2 milliseconds, 2 seconds. That means it will not be helpful for you to determine something, right? 90 requests took 1 millisecond, only 10 requests took 4 seconds. That means average is 2 seconds. So it is wrong, right? So that is how they were giving this functionality to help to identify only those 10 percentiles. So by that, so 99 percentile is up to 99th percentile is fine or 90th percentile is fine. Only that remaining 10 has the problem, then you can identify that and fix that issue whatever you can take. So this is how the one advantage we have. And Holt winter is like 2005 the country got some 100 okay, 100,000 visitors, and 2010 200 visitors, 200,000 visitors, and 2015 we may expect 3,000 visitors. That is how the whole winter has made a graph. This is not made by Prometheus. This function, this whole winter has already made this what is the theoretical explanation and proven also. This is a proven statement, proven formulas are available, and Prometheus has adapted that, made into the query, and when you apply this, it will take the data whatever is available based on history and it will show the future. Okay, this is how it will be. So currently if you are considered that we are in 2015 and 2016 will be like this, so 20 will be like this. So this is how the whole winter proposed, and the same has been adopted by Prometheus and they made the query available. And the clamp min and max, sometimes you no need to worry about that. Above some values I don't need itself. If this value is reached, that means something wrong. If this below this value, I don't want to care whatever they went down, but oh, why this reached this much below, that only enough. Why this much reached this below? So this is how the clamp min and max. So the clamp, you know, right, this is the symbol and we use it, can't go beyond that, it can't go beyond minimum. So I see this is the graph, normal graph is gone like that, but when I put clamp max, it is up to this much, up to this much, up to here. And when I put clamp min, it is not going beyond below. So this is how you are getting the graph like this. So it means something went below this, it means something above this, like that you can identify. And predict linear is one of the super good things that suppose the disk space is normal over the time and it is telling fine fine fine, but using predict linear, it will tell you before 4 hours it will, it is going to fill 100%. So this is a alert not there. That means once it reached here only will get alarm normally. But predict linear function will try to check that growth possibilities and it will tell here only in 4 hours this is going to be filled, please take care. So that kind of functions are available in Prometheus. You can apply this and see this. So the histogram quantile also we have discussed. Incidental quantiles are just the lines that divide data into equally sized groups. There is a technical definition, and technically speaking, percentiles are just quantiles that divides the data into 100 equally sized groups. Suppose whatever the data you have 1 to 25, I divide into 100, and from that whatever the percentile you want, I will go to that place. So whatever the data, even if you have 100 data, again it's 100 percentile. If you have only 25 data, again that will be considered as a 100 division, and it will find out the quantiles. So these are super functions available in Prometheus. We can apply these and identify the future problems, and you can do capacity planning, and you can stop some future issues, escalations. So this way monitoring will help you your applications smooth running and operation simplicity. By that way you can achieve everything. Hopefully we are able to see the technical theoretical part of PromQL. Let's check into demo how these functions helping and see observations. Thank you.